Yes, Mr. Sanjay, can you unmute yourself? You raise your hand. Oh, I think it was my mistake. Somebody has raised the hand. So, so shall we start now?
Yeah, you can start.
Yeah, please. Yeah, maybe we can go ahead now. It is 3:05. So, I welcome you all to this live session of the course Renewable Energy Engineering, Solar, Wind, and Biomass Energy System. So, this is the third live session. So this is the third live session, as you have already attended the previous session where your most of the doubts related to the solar and the wind, I hope is been clarified. So now if you have any query regarding this particular biomass system, biomass energy system, in that also if you have some queries related to the certain processes, that also you can we can discuss here. So when I saw the specific Excel sheet, the Google Excel sheet, I could see there are mostly three questions have been asked related to, one is related to the assignment question, and then other one is related to the job opportunities actually, which is beyond our scope of answering here. And then third is related to the refrigeration renewable. So I will go one by one in this case. Let us see when the first query is from Vikas Kumar. So where actually he mentioned that the specific example was given to calculate the dry cattle manure required in meter cube per day. I can understand that if an engine generator system is running in a biogas, running on a biogas, and is installed to produce around 40 kilowatt amount of electric power. So when you see this example here, so there the dry cattle manure which is required have been asked in meter cube per day. Okay, so the yes, yeah. So the reason behind this particular asking question in case of like meter cube per day is like there may be some typographical error in this case. So here when you do the calculation, the dry cattle manure required can be calculated in the kg per day, but then it also can be calculated in the meter cube per day. For that required we require a slurry density, but then it may be not the dry cattle manure. It is a total amount of manure which is required for the biogas production. So there was a typo there. I can understand that instead of meter cube, it should be a kilogram per day. So for that, actually, I am just sharing one screen here where you can see like how this particular example have been is done, so that you will get the idea about like how we have done this particular example here. Also, you'll come to know the exact solution for this. Okay. So can you see the screen? Anybody?
Yes, sir.
Yeah, if you see the screen here, so here if you see the statement, that's why I mentioned the statement also here, which is mentioned as the meter cube per day. So what happens sometimes actually in some of the examples, the thing is like we have asked certain quantities in the meter cube per day, certain quantities in kilogram per day. So when it is a dry cattle manure, I understand that it should be a kilogram per day, but sometimes when it is a total slurry which is required or total the manure which is required in per day basis. So once we have the slurry density, so based on that also we can calculate this particular value. But yes, I understand this should be a kilogram per day. This is a typo. So I hope you can you must have solved this in a specific way. But then just to clarify this particular example here also, I just mentioned the process steps like calculation steps also, that how we can calculate this particular value here. So say for example, in this case, if you see the engine generator system which is running on a biogas is installed to produce around 40 kilowatt amount of the electric power. So when this amount of power is getting produced, so there is a system in place. That means it has a generator, because obviously it will produce the power when you have the generator in generator system. So the generator efficiency itself is the 70%, and the engine efficiency which is used to couple this particular system is having a efficiency of 25%. So when you divide this, you will get the exact power which is input to the entire system to produce this much amount of power, 40 kilowatt amount of electric power. So that means because why we are calculating this? Because we need to know how much total input of power has gone into the system, so that based on that only we need to calculate how much amount of the material is required to produce this much amount of power. So if you see here, so this is basically you can say the amount of power which is input to the engine, which is a you can say the amount of input which is given to the engine to produce 40 kilowatt amount of electric power, right? So the quantity of gas which is required to produce this particular power now, because this is the power. So when the biogas, it is a biogas coupled system, so you require a certain amount of biogas to produce this much amount of power. So what is the quantity of biogas required in this case here is like how to calculate this, because for this we need to know the calorific value of the gas, right? Because the calorific value of the gas gives is the burning value of that particular material by which it will produce the specific amount of the energy, and that energy is getting converted into a electrical energy in this case here. Okay, so now if you see here in this case, for example, this is the power which is input. So to produce this much amount of power, how much amount of the gas is required in this case. So we know the calorific value of the biogas. So once you substitute the calorific value of the biogas here, we can calculate easily the total quantity of the biogas which is required. So as this is in kilowatt, we can convert it into a joule per second, and this value is already in kilojoule per meter cube. So you'll get the value in the form of meter cube per second. So now we can convert this into meter cube per second. Sometimes it may be asked to calculate in terms of meter cube per hour. So accordingly, you can change this value. It is in the meter cube per second. Okay. So now for the continuous operation, because now this is a continuous process. Suppose if you consider that the total amount of gas which is required continuously now in a whole day, because this is on second basis. So for whole day basis or per day basis, what is the amount of gas required? So you have to simply multiply it by the 24 hours in the specific 3600 second, and then the 24 hours. We have the 24-hour cycle, right? So based on that, you can calculate for the per day basis. So this much amount of gas is required on per day basis to produce this much amount of power. Clear? So now, once we know this is the amount of particular gas which is required on daily basis, so what happened in that case? Now, this is the gas which is required. Now, we know that the gas produced from the 1 kg of the dry cattle manure is given here is at 0.8 meter cube of gas. So now the total amount of gas which is required is also known. We know per kg of material produce how much amount of gas. So that is around like 1 kg of dry matter produces 0.8 meter cube of gas. Our requirement is 1313.28 meter cube of gas per day. So you have to simply divide this particular value by 0.8, which gives you a total amount of manure which is required on daily basis. And if you simply see here, so this meter cube will get cancelled, you will get the value in terms of the form of kilogram per day. So this is a simple calculation, because these kind of examples we already discussed in the regular sessions. So this is the example which is given based on that only. So there was small typo here, that is true, but while calculating you must have understand that, as the Vikas has raised this issue of like having the whether it is a meter cube per day or kilogram per day. So anyway, by that means it only changes the unit, but the value remains the same. There is no change in the value. Only the unit is changing here. Okay. So this is one query which was raised by Mr. Vikas. I can see here. Okay. So now Mr. Kura Prashant wants to know about the need refrigeration renewable. So Mr. Kura Prashant, are you there? Mr. Kura Prashant? I could not see him in the session, today's session. So I understand that refrigeration renewable, but as actually you know, this particular course is limited to a specific content where we have not covered this particular part of the refrigeration renewable. Okay, but then your point is well taken, and we'll see like if we can add some point on this particular aspect. But as such, the content of this course is already specified, and the course content as well as the syllabus is also properly framed here. So I don't think so we can do much changes in this, but your content of refrigeration, which is slightly deviating from whatever the syllabus and the content we have prepared for. So I think uh, maybe you can ask other kind of question if you are related to the content of the course, then it will be will welcome all those kind of suggestions. Another question I can see here, it is related to the ask question related to the assignment. Sonam, I don't understand this question itself. Sonam is there?
Yes, sir, I am there, sir.
Yeah, I did not understand your question. What you want to?
Sir, actually, the question number 1 and question number 7, they are giving the 1 marks before, after beforeing submitting to the questions. But after getting the marks, it was the my answer is right. But
There is a lot
but
of noise.
answer, but
Can you just, yeah,
but my answer is right, sir. But the marks carry 1 marks has removed from there.
remove from there?
Yes, sir. My
I can,
assignment number. I have
okay.
a screenshot also, sir. I will can send it to the that where we have done some
You
project
send it,
work.
yeah, you send it to my email ID. You know my email ID, right?
Email
I
ID, sir. I don't know your email ID.
My email ID I always give you at the end of the lecture. So you can see my email ID is
Okay.
there. So you just send it to me because CT you need to take care of this issue.
Hmm. Actually, sir, it is carry 10 marks now, sir. But
Yes.
in 10 marks, my two question is wrong, sir. Then it comes to if one carried 2 marks and one carries 1 marks. Then it comes to 70%. When after 2-3 days, when I have seen another log in the progress, then I have seen 62 marks, 62% out of 100. So then I just recall to my before assignment. Then I have checked there, ki, yeah, my answer is correct, but carry no marks. So that's why I
Oh,
have a fault.
okay.
Yeah,
Okay.
that I have a fault. So I just drop the message in there.
No, no, it's good you have done that. It's good because if some kind of technical glitch is there, we can always resolve this. So
Hmm.
I request the CET team to please take care. Is there anybody from CET here in the forum
Yeah,
now?
yeah,
Yeah, so please take care of this question of Miss Sonam. So, and try to resolve this. I already requested her to send me an email that I will forward it to you.
yeah.
Because
Okay, sir.
that
Can
is,
you please
yeah,
provide your email to me? I will take care, sir.
yeah, you please take care of this. There
Sure,
might
sir.
be some technical glitch. I can understand that. And then,
Sir, sir,
yeah,
in question number 7, sir, question number 6, a cattle manure. You just provide the
hello,
answer. I can understand.
which,
There is
which,
one more question, sir.
wait,
So,
wait,
sir, there is a data is insufficient. I think so that ki it might be, sir.
wait,
I
wait.
have
Which assignment? Which assignment?
assignment number 8.
Assignment number 8.
Yeah, 8. The last assignment, sir.
So what was the question? Tell me.
So, cattle manure. Right now, you just give the lecture. Yeah, this one only. Question number 6. 6666.
This one, right? So,
Calculate the input. Yeah, this one.
yeah, I don't think so. There is any insufficient data. I have given entire data in this case. You just see once and you let me know. Because here, what exactly we have done here, if you see, so the top portion here, this first step is top portion in the sense here, the first step, say for example here. So here the entire values are given in terms of the efficiency here, right? So once we have this value, we know the calorific value of the biogas as well, which is given here in kilojoule per meter
Yeah,
cube, right? So this is in the kilowatt. So basically kilowatt means we are considering there is like kilojoule per second here. So that's why it is a kilowatt because that is a representation of unit. Now once you divide this, you will get the value in terms of the meter cube per second. Now once you have the values in the meter cube per second, as this is in the second basis and we are always trying, because we mentioned that here we require on the daily basis the material requirement. Our requirement of the material is on the daily basis. So simply we are converting the second into the daily basis material requirement instead of second because it's very difficult to calculate the value on the second basis, right? When you are having the per day requirement, so the calculation of value on the second basis is not justified. So we need to know on the daily basis how much is the amount. So that's the reason we have converted the entire value only on the conversion factor here is like just multiplied by 24 hours and 3600 so that you can get into daily basis value. And once we have these values on the daily basis, so this much amount of material is required on per day basis. So if you see this statement here, it is mentioned 1 kg of dry cattle manure, it produces 0.8 meter cube of biogas. So what is the meaning of this? The 1 kg of material, if it is there, it produces 0.8 meter
0.8.
cube of gas. That means 0.8 meter cube of gas per kg of feed is getting produced when you are using this kind of manure. That is the simple meaning of that. Because per kg produces this much, means 0.8 meter cube per kg of biomass. So that's what we have done it here, like 0.8 meter cube per kg of biomass. You already know the unit of this. So if you just cancel meter cube, you will get the value in kilogram per day. So this is the final. So entire data is there, in my opinion. You just cross check once again. You try to see your calculation. Okay. And still, if you have any query, you can always write back to me. You use my mail ID. I already mentioned in the end of my lectures, every lecture. So just try to use that and send me all your queries. I will try to resolve all your queries. Apart from that, also, if you find in the next 1 week or 2 weeks after a certain
Yes,
case,
sir. Actually, from sir, one sir is Abhishek sir is from IIT Guwahati. He just came to from IIT Guwahati to BIT Sindri in Jharkhand side area.
okay,
Doc, Dr. Abhishek.
Abhishek, okay,
Abhishek, yeah, yes, sir. So then I just let it know that ki I also joined in PTL course, sir. And one sir has there, Vaibhav Vasant, sir. Like, yeah, I know know him. Like, sir, actually, I have some problem in the questions in assignment, sir, but I didn't get the perfect answer because last time also there's a confusion in my question, sir. So sir,
true.
like, okay, you just go and contact to me if any problem, then I will just tell to the sir. Okay.
No, no, you just write
Abhishek
to
sir,
me
yes,
directly. Yeah, you just write to me directly. So if you have any queries or any, you can say, maybe you are not understanding some particular part, you just let me know. So I will send you the step by step, the you can say solution for that particular example at least. In theory part, if you have anything, then also I will send you the proper content of that. So your things will get resolved automatically.
okay, sir.
Yeah, yeah. Do
Sir,
drop me
one
an email. Yeah.
एक मिनट sir, just 1 minute. Actually, there's a confusion in laptop. Wait.
Because in this session, mostly what I'm trying to do is like I'm trying to show you all the assignment answers so that you can see like whether you have done any small mistake while doing calculation. Because to my opinion, all these are very short steps, examples I have given in the assignment. So to just make you understand as well as to practice these examples, and then you can formulate your own examples based on these. You have to simply use this particular content of the example and simply you just start doing the calculation for those example. Just change the values and you can also try to change the statement of the problem even. So sometime what happens is like when I'm giving the statement in the specific manner, in the final exam, I may change it slightly. So you also try to think in that particular aspect, like what can be the changes expected in these kind of examples. Okay, so for example, if I see here, I will just show you a simple example of assignment 3 here, which is the first example itself. So if you see here in this case, it was asked to calculate the biomass feeding rate. So when it is a feeding rate, now I have mentioned kilogram per hour. So I can say like, okay, calculating the kilogram per second even to a gasifier. Now, if the power supplied by the gasifier to the engine is 1000 kilowatt, that means power supplied by gasifier to the engine means this is basically a output from the gasifier which is going to the engine is around like 1000 kilowatt. So now the gasifier efficiency is also given as 80% and the calorific value of the biomass because we are using the feed as a biomass here. So once we have the biomass as a feed, so we should know like what is the calorific value of this particular material. Rather than biomass, if we use a coal, if I change the material as a coal and I put a calorific value of the coal, that way also the examples can be asked, right? Similarly, I can mention here instead of the biomass or the coal, I can mention another kind of material which will I will produce some calorific value of that material as well. So those small changes can be always expected in such kind of example because these are very small step example, 2 or 3 steps, you'll get the answer. So in this case, as I mentioned, input to gasifier we need to calculate because this particular value of 1000 kilowatt is nothing but the value of gasifier which is coming out once we have the gasifier system and when we are injecting the biomass in that particular system, it produces power which is of around like this much kilowatt to the engine. So when this is coming as a output from the gasifier, so before that we need to know like how much input is basically required to the gasifier to produce this much amount of 1000 kilowatt amount of the power. So how to do that? Because we know the efficiency of the gasifier here. If you simply divide it by the efficiency here, it gives you a input which is there to the gasifier. So this is the input, and as the efficiency is 80%, if I simply multiply this particular value into 0.8, I will definitely get the answer of 1000 kilowatt, right? So this is input to the gasifier. So now to this much input of power, how much biomass is required to produce this much amount of to give this much amount of input to the gasifier? So you have to simply divide it by the calorific value because this is a power and we know this is a calorific value. Once you divide it by the calorific value, you ultimately get the answer in the form of kilogram per second. Now you convert it into kilogram per hour. So it's a simple two-step example just to practice it because this was the first assignment. So that's the reason I have given it a very simple example to practice as well as to understand that how we can just convert the one form of example into the another form. So here by giving the feeding rate also, we can ask you to calculate is like, sorry, suppose if I give you the biomass feeding rate, based on that I can ask you to calculate the input power which is required to the gasifier. So other way also it can be asked. So simply try to understand this example in this way and also try to calculate on your own by changing the statement of the example as well. So this is what I can suggest you also. Similarly, if you see the second example here again, this is another example in the same assignment. If you see here, in this case also it was asked to calculate the power which is supplied to the gasifier again. So now in this case, see here, in the previous case, I asked you to calculate the biomass feeding rate. Now I'm asking again here is like that, what is the power supplied to the gasifier now? Okay, if the system is replaces 70% of the diesel, means if there is an engine, so instead of using 70% of the diesel in that particular engine, I am replacing, suppose the engine requirement is 100% diesel. What I am doing in that case is like 70% of the material I am replacing with the gas which is produced from the gasifier. So that way I am just trying to save 70% diesel requirement of that particular engine. So practically 70% gas and 30% diesel is being used to run this particular engine here. So how much power is supplied to gasifier if the system is replaces 70% of the diesel? So that means here, like if I replace 70% of the diesel requirement of the engine, how much amount of power I need to supply to the gasifier so that I can replace this much amount of the diesel, that I need to calculate here. So in this case, the gasifier engine system, it produces this much amount of power. It is already mentioned here. So a gasifier system is producing this much amount of power. But when this is a system which is producing this much amount of power, now I need to calculate what is the input power which is given to the engine. That is very much important here because this is the output value now. But I need to know what is the required for the input so that I will get this much amount of output from that particular engine, right? And the engine efficiency here is 20% only. So this is also one of the factors we have to understand because the engine efficiency is very low here, only 20%. So now based on this, if I try to calculate, I know the output power of this particular engine and I know its efficiency. I can immediately calculate the input power which is required to the engine because simply I have to divide it by the efficiency here. If you see, this is the efficiency because that is the efficiency of the engine, only 20%. So as a result, what is happening is like the input power required is significantly high, and because of the 20% efficiency only, so if you just multiply 1250 by 1250 into 0.2, you will get 250 as the answer. That's why the output is coming as 250 kilowatt only. So we are just going the backward. We are doing the backward calculation here now to calculate the power supply to the gasifier. Now the system replaces 70% of the diesel, that is already they have mentioned, and the total input to the engine is around like 1250 kilowatt. So what is the meaning of this? That 1250 is the total input to the engine. Out of that, 70% is supplied by the gasifier. So if I just multiplied by the 70% here, that is the answer comes out to be around like 875 kilowatt. So this much amount of power I need to supply to the gasifier so that I can replace 70% of the diesel in the engine. So it's very simple to try to see this, right? So this is the way like one can do this particular calculation, and the remaining 30% is what? It is coming from the diesel. So if you just take a sum of these two, you will get 1250 as the answer. That is the kilowatt amount of power which is required as the input to the engine. So this is a very simple way of calculation we have given here for your practice, so that you can practice some examples. And another example in the question assignment number 3 only, if you see in this case, this was also very a simple example, simply you have to do some multiplication only. Say for example, if you are calculating the biogas which is produced, and for that the manure is given as a poultry manure, or you can say the poultry manure based biogas plant. So wherein this much amount of the chickens are present in the particular poultry, and the waste of that particular chicken is being utilized for the production of the biogas. Because this is a waste anyway, so if you utilize that particular waste to produce the energy, it's a waste to energy. So it's a very good conversion of the particular low value material to the high value, high energy material. Okay, high energy material in the sense is like, because the manure itself has very low calorific value, we are converting that into the electricity. So that is the advantage, that because of that it is converting into a very high value materials. So this is not a material but high value energy. Clear? So the dry manure produced in this case is given as this much, means 0.05 kilogram of dry manure it get produced per day from the per chicken. Per head in the sense here is the per chicken, and the percentage of the dry matter in that particular manure is 15%. Clear? So the remaining is nothing but what? It is mostly the moisture, and the biogas yield which is given in the example is 0.5 meter cube per kg dry matter. So this is the amount of biogas is getting produced when you have per kg of dry matter, it produces 0.5 meter cube of biogas. So I think this is very simple example which is given here in the assignment, because we know the particular thing here is like that. What example is given here is like dry manure. So dry manure produces around like 0.05, right? So per day per head. So immediately I can calculate here the dry matter which is produced from that particular poultry, because I know the number of chickens in that particular poultry. I simply multiply these two quantity here. I will get this much amount of dry matter produced from that particular poultry per day basis. But then when you do the biogas production, as you know, so we try to keep around like 15 to 10%, maximum 10 to 12% of the dry matter remaining. We try to keep it as a moisture so that we can make it as a slurry. So this is the dry matter produced. So now percentage dry matter in the poultry manure, we already know that is 15%, right? So now once we know this is the 15%, and I need to calculate now what is the total slurry, or you can say the total manure which is produced from that particular poultry. Simply I have to divide it by that particular percentage of dry matter, because this is the dry matter content in the poultry manure. Okay, I am just dividing it by the 0.15 here, that is nothing but the percentage of dry matter in the poultry, which will give me a total amount of manure which is produced on per day basis from that particular poultry. Clear? And in this particular, this is total. Suppose if I need to know what is the dry matter content in this particular poultry, I can simply multiply it by the 15 divided by 100, that is the 15%, right? So once I do it, I will again get the value of 17.5. So this is as simple as that. So once we know this is the amount of manure which is produced from this particular poultry now, so I can easily calculate the biogas produced here, because dry matter content I already know. This is 17.5 kg per day, and I know how much amount of the gas is getting produced from per kg of dry matter. So simply if I multiplied by that particular value 0.5, because this is per kg basis, this is meter cube per kg of dry matter. So this kg will get cancelled and I will get the value in the form of meter cube per day. So that is what is asked to calculate the biogas produced on meter cube per day basis from the specific manual, which is given here in the example. Isn't it? It's a very simple example to calculate. So only thing is you need to understand like what exactly the question and what has been asked to calculate in this particular question. So simply you have to use the terms which are given in the example, and in this case the percentage of manure, the percentage efficiency, these are very important data which is given here that you have to utilize very effectively and properly in the specific example that I will suggest you. And you can also practice this kind of example on your own. I will suggest you to practice these examples on your own as well. Similarly, if you see this example, I think this is one of the simple examples I have given in this assignment, that just calculate the thermal power available and all the data is given. You have to simply multiply it, because if you have gone through the lecture session properly, so the thermal power available can be easily calculated from the volume of the biogas which is available, its calorific value, and the burner efficiency. What is the burner efficiency? That gives you like the thermal power which is available, because the burner is nothing but what burner is, the gas is burning with the help of the burner. So the burner itself has certain efficiency. It may not be utilizing the entire gas for the burning purpose, right? So what is that particular efficiency? If it is a 50% or 0.5, nothing, 50% efficiency only, right? So I can simply multiply this value. I can get the thermal power which is available here. It is as simple as that. Again, so it's very simple example, just one step example. I just thought of like giving one step example here, so that let me see like whether you really understood the particular topic while attending the lectures or while attending the practice session of the examples or not. So that's the reason. Although in the practice session I have solved the entire example, assignment I have given only one step example, two step examples, three step examples, something like that. Or I just ask some specific thing to calculate the assignment as well. Because I can understand in the assignment, I cannot give the entire example as such total to calculate. So that's the reason I have given it on the specific topic basis, as well as the specific stepwise content of that particular example. Now here again, if you see, this is again the same example which we have calculated in the, I would say in the first one, meter cube per, or not here. Oh yeah, in the example number 7 or 9, which we have, whatever we have discussed earlier, where we have calculated the meter cube per second, then we have converted into a kilogram per second, and then we have converted into kilogram per hour, right? So similar is here also, because in this case, again we need to calculate the quantity of biogas which is required. Now it is in the meter cube per second. If you see here, earlier I was asking the example about the meter cube per day. I simply change it here now, meter cube per second. Clear? And the engine generator system which is running a biogas, it is installed here to produce the 20 kilowatt amount of electric power. So this is the amount of power which is getting produced here, that is 20 kilowatt amount of electric power. Clear? Now the generator efficiency and the engine efficiency both are given here, because it is mentioned here the engine generator system. So we require both the efficiency, that is the generator efficiency and the engine efficiency both. And the calorific value of the gas is always required in the example when it was asked to calculate the quantity of gas required, or the thermal power available, or the thermal power which is required. So you always need to know the calorific value of the biogas, and it is always given in examples. Maybe there is a slight change of 5% or 10% in the values, but accordingly the values are already given in the examples. So now here it is mentioned that 20 kilowatt amount of the power is getting produced, and we know the efficiency of the system. We have to divide by the efficiency of the system, which gives your total input to the engine. That is power which is input as input given to the engine. Means 100 kilowatt amount of power when you are giving as input to the engine, it is producing 20 kilowatt amount of the power. So that the conversion efficiency is like this. Clear? So once you know the power to the engine, now simply you can calculate the quantity of the gas required, because you already know the calorific value, which is kg kilojoule per meter, and your value is already in the kilowatt here. That is kilowatt means the kilojoule per second again. So if you just simply divide it by the calorific value, meter cube per second is the quantity of gas which is required. So if I ask you to calculate this on the meter cube per basis again, You have to simply multiply it by 24 over 3600, you will get the value in the form of meter cube per day. So this is another example. I just try to put it in some different manner here, which can be asked again in a different way, that you also try to think about particular example, how it can be asked in a different way. That also you try to figure it out from this particular example. You already have your assignment statements with you. I am just giving you the step-by-step solution also. You just try to go through it once again if required, right? This example I have simply just mentioned just now. I have discussed this example just now before, right? Another example, yeah, this is another simple example I have given in the assignment here to calculate. Basically, this was a new example I introduced this time in this particular content of the practice session of the examples, basically, where the requirement of the gas was asked to calculate, where we have only 4 lamps which are operating for 8 hours in a day, suppose, in a specific office, which is a remotely located office is there, for example, and the requirement of the light in that particular office is for only 8 hours a day, and they require only 4 lamps in a day. Okay, so now what is the gas which is required? Suppose if you have to enlighten this particular 4 lamp, okay, to light this particular lamp, what is the gas which is required in that particular case, and for how many hours it is required, that is already given. So how to do this particular calculation is very easy, because if you know the amount of candle power which is required for the specific one particular candle lamp and the amount of gas which is required there, then you can simply calculate this particular value for the number of, instead of 4 I can mention 8 also, I can mention 10 also. It doesn't make any difference. It will just change the value. Remaining everything is going to remain same, right? So for one, that's why I mentioned here, see, the gas required for lighting a 100 CP lamp. 100 CP means here is what? 100 CP means a single 100 candle power lamp. Means one particular lamp has a 100 candle power requirement. So that is based on that, and to do that it requires the gas of around like 0.125 meter cube per hour. So 0.125 meter cube per hour, if you just simply multiplied by the 8 hours, so you will get in the specific entire day the amount of gas required, right? And now if you just simply multiply by the number of lamps which are there in the office, it will give you a total amount of gas which is required, which is 4 meter cube per day, because in this case our day is basically for 8 hours requirement. That's why we are considering it as a 4 meter cube per day. This is simple as that. So one step example. So just to know whether you understood this particular example or not. Second example also I asked in the similar manner, but then I slightly changed the content in that. In that case, it was asked to calculate the thermal input which is given to the engine. Okay, wherein we have now, because thermal input to the engine, why we have mentioned here, because here we need to produce the electric power, because there are 4 or 8 computers which are mentioned in the examples, which has a capacity of 250 watt. We are operating this particular computer, which are 8 in number, each having a capacity of 250 watt. We are operating for 8 hours a day in the office using a dual fuel engine, a driven generator system. Okay, so in that case, what we have to do is like, we have to just calculate here the thermal input which is required to the engine in this case. So now to understand this particular example, if you see here, the specific example is mentioned as, say for example, the electrical energy which is required for 8 computers. So as we know, there are 8 computers are there, each required power of 250 watt, right? And 8 hours a day. So 8 hours a day here, which is there already, and 60. We are just converting this into again because this is on our 8-hour basis, right? So we have to convert this into enter value, because this is in watt. Watt means what? This is joule per second. So this is nothing but 250 joule per second. So as we want it specific seconds, so like we are converting on the second basis here, so that second will get cancelled and we'll get the value in terms of the joule, that is kilojoule or megajoule. So we have converted this value into the megajoule. So you can also use it as a kilojoule basis. If I ask you to calculate these values on the kilojoule basis, so accordingly you have to convert this value of megajoule into the kilojoule. That's all. And the thermal input which is required to the generator to produce this much amount of electric power is how much is the requirement, because you know there is a conversion efficiency of the generator is 80% and the thermal efficiency of engine to be around 25%. So what I have done is like simply I divided by the efficiency of that system, that is generator is the separate system and again you have the thermal efficiency of the engine as a separate system. So I just divided by the two efficiency values. I got the value that is 288. So that is the thermal input which is going to the engine here in this case. Okay, so that we can simply see here like how simple example again. I will just slightly change this particular requirement here and ask to calculate the thermal input to the engine. So that way, these small examples can be solved. You just try to figure out this kind of. So you'll come to know like how easy to calculate this particular example. It's very easy. Similarly, this one example, I think this is slightly a different example. This time I have given in the assignment just to see like how you can solve this example here, because this particular part I have discussed in the lecture, but I have not given the example of this sort in the earlier this one session also. But this time I thought of giving this particular example. What is the example is like, say for example, when you have 30 gram of carbon and when you are burning this particular carbon completely, so completely in the sense is like there is a complete combustion of that particular carbon is taking place when you are using air or oxygen as a oxidizing agent in the specific system. So it produces this much amount of kilojoule of heat and this much gram of CO2. Why it is so? I asked to calculate the gram of CO2 because when it is a complete combustion, so you know what kind of product it is going to form because it's a complete combustion. When it's a complete combustion, you'll mostly get the CO2 as a product because this is the pure carbon which is given here. So mostly you'll get the CO2 as a product, right? So when you know this, so for this particular reaction, you know what is the heat of that particular reaction. So it is already given in the so one of the lecture if you remember it properly. So this is 394 kilojoule per mole of that particular carbon. This is produces this much amount of the heat, right? So now once we know that this is the reaction and we know 30 gram of carbon we are burning completely to produce this much amount of the energy, then how much amount of CO2 is getting produced in this case? So it's very simple example. Say for example, if I consider this as a 1 mole of carbon using this stoichiometric equation of that particular reaction, 1 mole of carbon, I know it is equivalent to a 12 gram of carbon because this is a molecular weight of the carbon as you know, right? It produces 1 mole of CO2, that means 44 gram of CO2. C is again nothing but the 12, O2 is 32, you will get the 44 gram of the CO2 and the heat produces this much. We already know this particular value. Now instead of this mole, I am just converting it into the gram because the values given are in the 30 gram basis. So when we have the 30 gram of carbon here, that means how many mole of the carbons are there is nothing but 2.5 because simply we are dividing it by the 12 here, right? So we are getting 12.4, 12.5 mole of carbon in this case. And when it is producing, one carbon is producing one CO2. So similarly, it will produce 2.5 mole of CO2. It is as simple as that. So you are simply multiplying this 2.5 mole into the 44. That means again the molecular weight of this CO2 here. You will get 110 gram of CO2. This is the amount of CO2 which is getting produced when we burn 30 gram of carbon, which is the assumption is like complete combustion of the carbon is taking place in this particular case. So now when this is happening now, so for 1 mole of carbon, because these values are given for per mole of carbon, right? So now for 2.5 mole of carbon, if you see here, what is the amount of it produces? Nothing but so likewise, very simple example statements I have given. This is also one of the simple example here. All the values are given, whether it's a air to fuel value or whether it's a theoretical air requirement or what is the combustion value which is required for the specific. This one is already given here in the particular example for the specific way. We have to just calculate the equivalence ratio. As you know, the equivalence ratio, it is ratio of the air to fuel ratio, which is stoichiometric divided by the actual one. That is stoichiometric is nothing but the theoretical one, and if you divide it by the actual one, so you will get the particular value here. So now here in this case, as you know, the theoretical requirement is given than this one, because obviously, but the actual value will be obviously more than that, because it is not the ideal systems here. So obviously we'll have the more value. So as the reason here, if you see, if you try to divide this, you'll get the answer in the form of 0.67. So it is simply you have to put the value here. You don't need to do anything. If you just simply remember this equation, so you can calculate this particular equivalence ratio. It is as simple as that. Clear? So on the similar line, another example was given here in this case. If you see here, this is another example where, yeah, this time actually this was the example given, which is slightly different than the what was discussed in the example. But this is one particular step of that entire example which we have solved in the practice session of the examples. Okay. So in this case also it is the same one. The methane was combusted in a pure oxygen environment. Okay, that is the oxygen, the pure oxygen which is getting used here. There is no nitrogen there, as there is no air, so there is no nitrogen in this. So the constant with the O2 concentration of 6 mole percent in the flue gas. That means what is happening in this case is like there is some excess gas is getting fed inside the gasifier during this particular combustion process. Sorry, in the combustor. So as a result, some amount of oxygen is coming out in the flue gas. What is the meaning of this? There is a excess air, or there is a excess oxygen was supplied. That's the reason that much amount of oxygen is coming out in the flue gas. If you say the actual requirement as per the stoichiometry, then the oxygen should not come out. If it is coming out, means the excess oxygen was supplied, right? So determine the operating oxygen to fuel molar ratio for this particular reaction. Means what is the operating oxygen, or that's why fuel to oxygen to fuel ratio which is required for that particular system here. Just that we need to calculate. So as you know, the concentration of O2 in the flue gas is given as a 6 mole percent. That means 0.06 mole fraction. This is a 6 mole percent is the oxygen along with the other flue gases. If I convert that into a mole fraction, it will be a 0.06 mole fraction, because we consider the entire percentage as 100 mole percent suppose. So in this case, 6 mole percent is only oxygen. So remaining 94 are something other gas composition in the form of CO2 and something, right? So that is the total mole fractions of that particular gas. Out of that, only 0.06 mole fraction is of the oxygen. So this value is given. So this is very helpful, because once we know this value, then only we can calculate the specific amount of the oxygen which is required for this particular reaction to take place, so that we will have 6 mole fraction of the oxygen in the flue gas. Clear? So CH4, because methane, so it's a CH4, and then we know 4O2, it gives CO2 plus 2H2O. That is a theoretical oxygen which is required. So now in this case, there is no oxygen, there is no plus oxygen. That means the oxygen is not coming out in the flue gas. That's why it is called as a theoretical oxygen required for the specific combustion to take place. But now in our case, what happens is like 6 mole percent of the oxygen is coming out in the flue gas. That means when you are burning a methane as a gas, so we don't know what is the number of moles of oxygen which is required here now to burn 1 mole of the methane, because we know the product is coming out as a CO2, 2H2O plus now N minus 2 O2. Why N minus 2 O2? Because we have 1 mole of oxygen here, 1 mole of oxygen here. So that's why N minus 2 will go out here. So the remaining percentage of or mole of oxygen will be coming out as it is from the flue gas. That's why it's a excess oxygen. Now, if you remember our examples, so the mole fraction of oxygen in the flue gas, if I need to calculate, how to calculate that? The moles of oxygen in the flue gas. So I know moles of oxygen in the flue gas is N minus 2 divided by the total moles of the product in the flue gas. That means 1 plus 2 plus N minus 2. So if I just solve this, because this is one equation, we have only one unknown here, that is N, I will get the value in the form of 2.2. So 2.2 moles of oxygen is required per mole of fuel to have this kind of combustion, where we have 6 mole percent of the oxygen in the flue gas. Very easy, right? So simply you need to make yourself understand like how it is happening. And this is another example in the similar line. I have mentioned in the assignment number 10, which is the last example of that particular assignment. Here, it was again asked for a biomass gasifier, which is operating with 180 kg per hour of the biomass. Feeding rate was given here, and it is used to run a compression ignition engine, basically. And the engine has 32% efficiency, and it operates in the dual fuel mode with 80% diesel replacement. That's why it is a dual fuel mode. Dual means it is using diesel as well as the gas which is produced from the gasifier as a fuel. That's why it is a dual fuel mode engine is there. And because of that, we could able to replace the 80% of the diesel requirement of that particular engine, as we are supplying the gas as a fuel to that particular engine. Okay. So this gasifier engine system produces this much megajoule of energy per day. Now we need to calculate the gasifier efficiency if the calorific value of the biomass is given as 16 megajoule per kg. Means here we have to calculate the gasifier efficiency. It is completely completely a different orientation of the example we have given here. So otherwise the most of the contents are same, but the way of solving this particular example is totally different now. If you see here, because the feeding rate is given, that is 180 kilogram per hour. That is the biomass feeding rate to the gasifier. Okay. So now once you know the feeding rate, we also know the biomass calorific value. Basically, it is given as 16 kilojoule megajoule per kilogram now. Now it's not a kilojoule, but it's a megajoule per kilogram, right? So you have just converted this into the kilojoule per kilogram just to have the uniformity of the consistency of the unit. So now once you know the biomass feeding rate, this is the biomass feeding rate. We are converting this value again in the second, because we need to know the efficiency of the engine, because we have to calculate again the power which is because yeah, it is mentioned here the gasifier engine system produces this much amount of energy per day. Okay, so we need to calculate the power input to the engine. So based on that only we can calculate the efficiency of the gasifier. Otherwise, we will not be able to calculate that. So for that reason, we have just converted this value into kilojoule per second, because this we know kilojoule per kg. This particular value is in the kilojoule per kg, so that your kg will get cancelled. You will get the value in the form of kilojoule per second. That is nothing but the kilowatt. So this is the power input to the gasifier, because this much amount of biomass is getting fed inside the gasifier, where it has a calorific value of this much. So once it burn, it will produce this much amount of the power. So power input, this is the input which is given to the gasifier now. So now once this is the input which is given to the gasifier, so the energy which is produced by the engine per day is nothing but 17280 megajoule of energy, which is on per day basis, right? So now once we know this value, which is a energy which is produced by the engine is 17280 megajoule. So the power output from the engine can be calculated very easily, because we know the this one efficiency here. We know the values here for that particular conversion. So since it is a 17 to 80 megajoule per day, so what we are doing is like we are first converting into the hour, then into the second. Simply we'll get the value in the form of kilowatt again here. Clear? So this is the power which is output from the engine. That is what is mentioned. The gasifier engine, its system produces this much amount of energy per day. So this is the, we are just converting this value into the power in terms of the kilowatt, so that we'll have the uniform units across, so that we can directly do the calculation at the end. So this is the power which is output from the engine, right? So now we know the efficiency of the engine is 32%. So if this is the power output, what is the power output to the engine now? We have to simply divide it by the efficiency of that particular engine. This is nothing but the power, or you can say the total power input to the engine is 625 kilowatt. So when we give this much amount of power input to the engine, it produces 200 kilowatt amount of the power. Isn't it very easy? Now we know that this particular system, it is operating in the dual fuel mode. It is replacing 80% of the diesel. That means 80% of this total power is coming from the From where? Gasifier. The gas which is getting produced from the gasifier, that is being used as a fuel to produce that particular amount of power, right? So now once we are replacing this 80% of the diesel, so what we have to do is like simply we have to calculate the power which is supplied from the gasifier to this engine is nothing but 80% of this value. Pointed into this total power, if you do, it is 500 kilowatt is nothing but the power which is supplied from the gasifier. And remaining is coming from the diesel as a fuel. Simple. And once you know this is the power output from the gasifier, we know the power input to the system. So power input to the system we already calculated here. That is nothing but the 800 kilowatt. This is the power input to the gasifier. If I simply divide this, I will get the efficiency of the gasifier as 62.5%. It's very simple example. Clear? So this is example with the slight changes, or you can say the slightly change that way of asking this particular calculation. It's slightly different what we have discussed, but it is in line with what we have discussed in the regular class sessions. Okay. So this is the way like we have done this calculation for this particular oral examples, so that you can note down all this particular calculation for the assignment example also, and as well as you can cross check your answer also here. Okay, so this is all about this particular thing. If you have Vikas Kumar, yes, if you have any question, because I was just describing first the assignment question so that most of the answers will get clarified there itself. Yes, Vikas Kumar. So any other query from the other members? Because I could see.
Hello, sir.
Yes.
Excuse me, sir.
Yeah.
Sir, in assignment 8, question number 6, sir, means so in what way we have to find out the units I am telling, sir? That is the kg per. If the answer is coming 16 point something, that is the 161613. I have, sir, sent you the question also. So
Yeah,
please
yeah.
see now.
I explained that example. Yes, I think maybe you are not there that time. So I already done that calculation and I already explained to all the members. Yeah, that is what you have mentioned is like whether it should be in the kilojoule per day, no, kilogram per day or meter cube per day, right?
Yeah.
Yeah. So this is the example here. If you see, so this was in kilogram per day. You are right.
Kilogram per day.
Yeah.
But what it is written in the, sir, question,
Yeah,
sir?
yeah. It was actually,
See, we have to find in the dry kettle manure required meter cube per day.
yeah, there was like typo mistake was there, meter cube. Because sometimes what happened when
But sir, see, sir, I have got the answer. That is the I think option number something. Okay, I'm just finding out, sir. That option A is correct, sir. Because if it is meter cube per day, then option A is correct, sir.
yeah,
You can
yeah,
calculate it.
you can that's why I said you can calculate in both the way. But when you have mentioned it is as a dry cattle manure which is required.
Meter
So,
cube per day, then answer A is correct, no, sir. Then my marks would be got, no, sir.
so what is your answer?
That is the okay, sir. I'm finding out the. Actually, I don't have the assignment now. I'm just getting the assignment, sir. Question number 6, you see, no, sir. The first 13 something coming my answer, sir. 13 something coming answer. The answer is coming 1313. Something is there.
1313. See.
Yeah. 1313. Yeah, that answer is coming, sir. You see, no. If it is not converting, no, 1313. The answer is coming, sir. Meter cube per day.
That's what I'm saying. You just see here. When it is a 1313, it is a gas which is required. It's not a manure which is required. So this is the gas which is required. The value which is coming in meter cube per day. You have done calculation properly. I understand that. There is no issue about that because you saw the unit as a meter cube per day. So you have stopped your calculation at meter cube per day. But this value is for the, yeah, this value is for the biogas which is required. So what we ask is like the dry cattle manure which is required.
Okay, I understood, sir. What you are telling, I understood. But sir, you should just. I have
No,
seen
that
the
is,
unit, and that's
yeah,
why I
because
have.
I just
I wish-
noticed this issue of change of unit. So I will ask them to give marks for both one.
Yeah,
Okay.
yeah.
Yeah, those you have done
Yeah.
for kilojoule per kilogram per day, and those you have done for meter cube per day.
Okay, sir.
And that rectification of assignment will do. Because
Okay,
I noticed it just now. Yes.
okay.
Yeah.
Thank you, sir. That
Yeah.
was the big mistake, sir.
Yeah, I saw your query. I saw your query in the Google Sheet.
Oh,
Yeah.
thank you, sir.
Any other query from other members?
No, sir.
Okay. So,
Okay, thank you.
yeah. Welcome. I will. I'm here to clarify your doubts only. So there is no issue. So we'll take care of this point of example number 6 in the assignment 3.
Okay, sir.
Yeah. So if there are no more queries, so I ask the CET personals to maybe we can close the live session now.
Yeah, you can close, sir.
Okay.
Sir, 1 minute, sir. Yes, sir,
Yeah.
your email ID, sir, you just told me, no? That after
Yeah.
ending of the session, I will send.
Oh, okay. I will just type it here. You can just in the chat box if you see. I'm just typing here. Can you see? I've just posted now.
No, sir, it is something, it is very small, sir. Can it be a bold letter, sir?
Can you see this chat box?
Yeah.
Just check it here. You just note down that mail ID and just send me that query which you had the assignment. Okay.
Sir, it is not clarified. My laptop, sir, it is not clarified. Sir, should be it in a very big size, sir?
No. You just see on the
Spelling.
chat box on the top you have people chat reaction. You just click on the chat. Can you see on the top side of your laptop?
Yeah.
So you have certain symbols on the top: people, chat, reaction, more. Do you see that or not? Otherwise, you just write down. I will just tell you VV Goud, V for
Yes,
Victor.
sir. You just tell me. I will just going to write down.
Okay. So VV Goud. V for
VV.
Goud, Goud, Goud.
Okay.
@IITG.
ITG.
.ac.in.
.ac.in.
Yes.
Okay.
Yeah. Okay, then we'll wind up this live session. And if you have any further query, you can just drop me an email. Okay, so that I will try to answer your queries then and there itself in the email. Thank you all for attending this live session.